Hello, Charger family. This is Mrs. Boyd. Mrs. Boyd's math room. Dropping stuff on the floor. Holy cow. All right. I hope everybody's doing good. Today, we're going to talk about the illustrious inequalities in one triangle. My children are being really crazy in the background. If you hear some yelling and screaming, it's just them. No need to worry. Let's go ahead and get started. We're going to look at the angle-side relationship. This tells us if AB, this one right here, is greater than BC, this one right here, then the measure of angle C is greater than the measure of angle A. Let's talk about how that's possible. So we're saying this side length is longer than this side length. So the sides are going to correspond to the angles that they face. So if you can imagine, angle C is right here. The side length it corresponds to is AB, the only side that's not included in the angle. So AC is one leg of the angle. CB is the other leg of the angle. So AB, the side it's related to, is across from it and not related to the angle itself. So that can also be said, angle BAC, angle A is related to side BC because AB is included in the angle, AC is included in the angle, so BC is the only side that's not included. That's the one that it's kind of related to. Okay, so if the side is bigger than another side, then the angle it's related to is bigger than the other angle it's not related to. We can relate things kind of like that. I don't know that I described it very well, but we're going to try it out. So we're supposed to list these angles. All right, so if AB is 5.6, BC is 4.8, and AC is 4, we want to list the angles from least to greatest. So angle C goes with AB. Angle B goes with AC. And angle A goes with BC. So the largest angle is with the largest side. Okay, so the largest, oh, this is L is for least. Oh my gosh. This is least to greatest. Oh Lord, it's been a day. All right, so the smallest side goes with the smallest angle. So the smallest side is 4, side AC, and that goes with angle B. So that means angle B, the measure of angle B is the least. The next smallest side is 4.8, and that's BC, and that corresponds with angle A. So the measure of angle B goes first, and then the measure of angle A. And then last but not least is the measure of angle C. So you find the side and the angle that are related, and then you compare the sizes of all the sides. Let's do some more. Let's find out the angles that are related with which sides first. We've got angle E is going to go with side DF. Angle D is going to go with side EF. And then angle F is going to go with side ED. So this time we're going to list these from greatest to least. So the greatest angle is going to correlate with the greatest side. Greatest side is EF at 5. So that means the greatest angle is the measure of angle D. The next greatest side is 4, and that's side DF, and that's related to the measure of angle E. And last but not least, the ED is 3 and it's the smallest angle. So that means the measure of angle F is the least. Let's look at this next problem. Looks a little bit different than what we've had before. We've got two triangles together. We need to determine which of these angles. We have triangle JMK, triangle MLK, and triangle JLK. So don't forget the biggest side is going to go along with the biggest angle. Well, right now, the biggest side is 9, right? And that's triangle MKL or triangle MKL. If we add JM and JL or an ML together, side JL becomes 9.2, and that will be the biggest side. That corresponds with angle K. Let's call it something better than that, though. So the greatest angle in this case is going to be the measure of angle JKL, the angle that goes with the whole triangle, not just either of those halves. All right, now let's look at the side angle relationship. If the measure of angle C is greater than the measure of angle A, so let's see how these angles correspond with the sides. Got angle A that goes with BC, angle C that goes with AB, and get this to work. There we go. Angle B that goes with AC. So if measure of angle C is greater than the measure of angle A, that means C is bigger than A. C is bigger than A. So if C is bigger than A, then it goes with side AB. So segment AB is going to be greater than the one that corresponds with angle A, which is BC, and segment BC. Let's put this to the test. Let's put the angles and the side lengths together. I know that angle A goes with CB, angle C goes with AB, and angle B goes with AC. We're going to list these from least to greatest. So the smallest angle is angle A, it's 40, and that goes with segment CB. So our smallest segment is going to be segment CB. The next smallest segment is going to correspond with the angle that's 50, and that side AC. And then finally, angle 60, angle C is 60, and that corresponds with AB. Now, triangle DEF has left out some parts that we might need to be successful. So if we know that angle D is 30 and angle E is this right angle, we don't know angle F. Well, we know the right angle is 90. So to find angle F, we can do 180 minus 90 minus 30, and we get angle F is 60. Now let's decide which angles go with which sides. Angle D goes with side EF. Angle E goes with side DF. And angle F goes with side DE. This time we're listing from greatest to least. The greatest angle is angle E at 90 degrees. So our greatest side length will be segment DF. It's also called the hypotenuse, by the way, in right triangles. The next greatest side, or the next angle, is 60 at angle F, and that corresponds with side DE. So that's the next largest. And finally, we've got side D, or angle D, that corresponds with side DEF. All right, so we've got another problem like we had before where we need to say which of these sides is the greatest. Okay, let's look at this here. We're going to look at these triangles separately. First, let's look at triangle JMK. I drew right through all of that stuff, so let's just get rid of that. All right, so triangle JMK, largest side will be side MK. And that one is larger than side JK, because M is the next biggest angle. And that's greater than angle K, which is side JM. Let's look at triangle MKL now. Largest side is ML, and that's bigger than KL, and that is bigger than MK. So here's what we do. We're going to put these together. We see that there's an MK here and an MK here. So we're pretty much going to hook these two MKs up and leave all of the angles in the same spots. So first we'll have ML. It's the greatest of the greatest, followed by KL, followed by MK, which is shared with both triangles. And then that's followed by JK and followed by JM. So our biggest side is side ML. So just to recap, you listed each triangle in order. This was the red one. And then the orange triangle, you put that all together, MKL. And then we listed all those angles. Well, MK was at the smallest of one triangle and the biggest of the other one. So we put the smallest and the biggest together and then wrote all of those in order. So ML turns out to be our biggest side. We're going to look at it again here in just a few minutes. If you didn't get it, I hope you will here in a minute. Let's keep moving on. We're going to look now at the exterior angle inequality. This says that since measure of angle A, which let's look at that, is right here, plus the measure of angle B equals the measure of angle BCD, which we have learned this before, then the measure of angle BCD, which is right here, is greater than the measure of angle A, because you have to add A with B to get BCD. We also know that the measure of angle BCD is greater than the measure of angle B. So BCD is greater than either one of the separate parts that make it up. Let's put that idea into some action down here. We know that measure of angle 7 is right here. This angle right here is 7, plus the measure of angle 9. So we have these two angles inside of the triangle. The only angle we don't know is angle 8. So if we add up 7 and 9, we find the angle that it is not included in that addition, and the linear pair with that one is the one that that angle is equal to. So 7 plus 9 is equal to the measure of angle 6. All right, so we used 7 and 9. 8 is the only angle we didn't use, so the linear pair with that is the sum of these other two angles. Okay, this is going to take you a second to grasp. I think, maybe not. You're going to get it right now. Let's try some more. Measure of angle 1 is right here, plus the measure of angle 2 is right here. So we have those two in the triangle. Only one we're not using is angle 3, so the linear pair that goes with that, angle 5, is what the sum of those two angles is equal to. Let's look at some more. Here, erase my marks here. Maybe not. Oh, apparently not. So measure of angle 8 is here, minus the measure of angle 5 is over here. So 8 is a linear pair with 6, and it's right outside of this triangle 4, 5, 6. We take 8, we know that 8 is going to be equal to the sum of 4 and 5. So if we have 8 and we take 5 away, we can only be left with 4. Let's try it again. Measure of angle 3 is what we have. We know 3 is equal to the sum of 4 and 6. We have 3, and we take away 4. We know we're going to be left with the measure of angle 6. So I know there's a ton more stuff on this page, a ton more. I mean, a ton. The whole of what I want you to know is contained within these 4 questions, okay? If we can just remember the initial meaning of this exterior triangle inequality, where we add angle A and B together and get BCD, that's all, excuse me, goodness, that's all I'm really concerned about. The rest of those things at the bottom of the page are not nearly as important to me. So remember this part. You're going to have questions like this on your homework today, and you're going to have questions like this. So be sure you know how to do these 2 kinds of things. And let me know if you have any questions. I hope you're fantastic. Reach out if you have any questions or problems, and I hope to see you soon.